Yeah, stream is good. You should be able to. Oh, nope, nope, I lied. All right, try now.
Year and a half or so. I've been working with React for about 4 years. Um, so, and I grew up in Anchorage. I went to West High School. Trying to move back to Anchorage. So hopefully that'll happen for me as soon as anybody can move anywhere. So what is React? It's a UI library. It's an important distinction because a lot of the things that we work with on the front end are actually frameworks. Things like Ember or Angular sort of have more of an opinionated approach to how you structure your project and the model you use for building your front end applications. But React really doesn't. It only does one thing, and that's render UI. And it has an opinion sort of about how it does it, in that you use components and you kind of have to have a one-way data flow. It goes top to bottom, and there's nothing you can really do about that except for go with that flow. It makes a tree of components that renders. But since it doesn't require an architecture, there's like no templates or requirements for anything. It can it's pretty easy for React-based projects to sort of get out of control or like lose its structure. So it's important to keep it in line, and the only thing that is keeping it in line is like you and your best practices. And one of the best tools you have in your toolbox for that is making good components with solid APIs. So it's an API. This is something that we all know about, like sort of intuitively, I think. Like we think about it. So I Googled what was an API, and the first image that came up was this image. And this is how I think of an API. It's a backend system that exposes an API, and it's an API for interacting with your service. Like that's how we usually think about it. If we think about it harder, we always usually say like, yeah, okay, it's a means of interacting with any black box of functionality. Which is sort of what that quote at the bottom is getting at, with which is from Wikipedia. It's important to think about React components as they are a black box of functionality. They do have an API, and it's important to think about the users of your component when you're building a component, because that user is probably going to be you next week. So you're probably going to be happy that you thought about it. So what should we be shooting for? What is a good React component API? It should be declarative. We'll get into declarative versus imperative in a second. But one of the great advantages of React, one of the reasons it's great, is that it is declarative. It just does the things you want it to do. You tell it what you want it to do, and you don't have to like explicitly spell everything out. Composable is always good. Flexibility in use is great. As we know, over time, software tends to get more complicated, require more edge cases, more uses. So the more that you build in up front, the happier you'll be at the end. And it should be simple to use. That's the goal of any API in any context, is that people like using it because it's easy. So declarative versus imperative, what's the difference? On the left, I have a React component here. On the right, I have a function that manipulates the DOM of the browser. React is declarative, the DOM is imperative. With React, you just say, there's a div, there's an image, make it so, and React does that for you. With the DOM, I actually don't know if this code works. It's been a while since I've interacted with the DOM directly, but you have to tell it like, hey, make a div, and then append an image into that div, and then append that div to the body document. And so you're like mutating things like in a step-by-step fashion. So it can get really hard to keep track of what's going on over time. So to illustrate all this, I spent hours making this like really beautifully designed website, which is my hot new startup. It's called Dog Space. It's a social network for dogs where they can make profiles about themselves. We'll use that as our basis. So any React developer, usually when you start out making an app, you either start from a wireframe or like a drawing on a napkin or whatever. You kind of like start with what the page is going to look like at the end, and you start dividing that up into components in like logical places where you break this website down into little pieces. So I've done that here with some red boxes. And this for me has always been the hardest part of React development is where do you draw those boxes and how do those boxes interact with each other? So that's what we're going to tackle. So we're going to start specifically looking at this breadcrumb right here. Really simple component, ostensibly, that is pretty common. So the first thing we do is like, cool, we have a breadcrumb. We need to make a breadcrumb that can render some amount of things in it. And React is really great at rendering lists of things. It's one of the things it does best. So cool, we'll just do that. We'll take in a list of items that are our breadcrumb items that we'll render. We'll take in a change handler that will fire when somebody clicks on a breadcrumb. Great. So we're gonna make a little container for our breadcrumb so we can style the whole thing and how it lays out. And then for each item that gets passed in, we'll render an item that will actually fire that onChange event and when clicked and render the breadcrumb text. In this case, items is an array of strings. So if we look at how this works, like on the front end, or how our users are consuming this thing, they have a breadcrumb component. It takes in some items. So, home, dogs, and then the specific dog, whose name is Potato. And then it takes non-change, which with the change handler that'll handle what happens when we do stuff. This is pretty easy. It's pretty simple. This actually is totally fine. Like, no problems here. But as we know, software kind of never gets simpler over time. Like, features always aggregate, feedback always exists. So as time goes on, the dogs are clamoring that they don't like the blue breadcrumbs on their profile page. They would prefer that it be pink sometimes. So you have to update your styles. So some pages it's going to have a blue breadcrumb. Sometimes it's going to have a pink breadcrumb. So what you need to do is have dynamic styling. So no problem. So now we can, in order to let that happen, we need to pass in a class name in order to style our container in case those styles need to change. And then we're going to just take in a class name for our separator, which is this little slash right here, in case we want to style our separator. And then we have our items, but our items are no longer an array of strings. Our items are an array of objects. And the object is going to have the text that needs to be rendered for each individual item. And it's going to have a class name to style that individual item. So what that looks like here as a user of this component is now we've got an array of objects. And each object needs to specify the text that's going to be rendered. It also needs to specify the class name of the style that's going to control how this thing looks. Then there's sort of the separator class name that's hanging out there. And it's like kind of related to items, but it's also kind of not related to items at the same time. Either way, it's getting like, this is still like reasonable, but we're starting to ask a little bit more of our users to understand what the options are when they try and use this thing. If I were to come back the week after writing this and I'd forgotten exactly how it was going, I'd probably have to look at the implementation of it to know that I can pass text and class name as my object keys. But now the dogs are clamoring because they really don't like those slashes between the breadcrumb items. They actually want emojis of dogs instead. So we need dynamic markup as well as dynamic styling, which we can totally achieve with our current API. We're going to pass in a class name, and that's going to style our container again. But now we've moved the items class name and the separator class name into the object of items. So now we have to pass in the text that we're going to render for each breadcrumb item, the class name to style that class name. We also know that now like all bets are off. So, you know, in our markup, we actually have a container around each individual item in our breadcrumb. So we're just going to pass a class name for that too. We're going to pass a separator, which is the actual markup, whether that be an emoji or a slash, and we're going to pass a separator class name. So how that ends up looking is this, which is a big yikes. Like this isn't a fun component to use. I have no idea what's supposed to go in that object anymore. If I even were to look away for 10 minutes, I would forget what was going on here. And it's not very fun. So I think like, well, whatever, maybe I can make this look good by just abstracting the creation of items into a method. So I'm going to start with my happy place where we first began with an array of strings. I'm going to map over those. So for each thing, I have my text, which is great. I can put that right in my object. And then I have some heuristic around how this thing needs to get modified before we end up with the shape we need to render a breadcrumb. If it should be pink, add a certain class name. If it should have an emoji separator, do something to the separator. But like what this code looks like is really bad. And it's imperative. Basically, we're mutating an object sort of until it looks like something. And we're not totally sure exactly how it's going to be at the end. We are for now, but over time, it's just pain. So why is this happening? It's because the API of our component is bad. we're exposing the internal complexity of rendering a breadcrumb to our users. We optimized for making a simple component, and that made it hard to use. And that is pushing our users towards a more imperative programming style. Part of that's because our breadcrumb is trying to do too many things. It's trying to render the breadcrumb itself, like the whole container. It's trying to render each individual item. It's trying to style the container. It's trying to style each individual item. And then it's trying to also render and style the separators between each individual item. So there's that's a lot of things for one function to keep track of, because at the end of the day, a React component is a function. So it's important to keep that in mind. So how would we improve this? We want to get back to being, instead of that unhappy child with his bricks all over the floor, we want to be this happy little girl putting together brightly colored bricks in a way that makes sense to us to create something beautiful. So let's imagine what a declarative breadcrumb would look like. And that's that we have a breadcrumb that has a change handler. It knows when certain things are selected or not. And we have each individual item that knows how to style itself and what it needs to render for the actual text inside the breadcrumb item. So sometimes it could be the text home, it could be an emoji, it could be whatever. We don't care. So how would we do this? We would do it this way. Threw together a quick breadcrumb component that renders whatever items are inside it. It's actually two components. And the take-home message of this isn't necessarily the implementation detail, so much as that it's kind of complicated. It's just a breadcrumb, but there's kind of a lot going on. We're doing React.children to array. We have to be more defensive now, because now as the providers of the component, we're just expecting our users to put things inside of the breadcrumb. And we're hoping that the breadcrumb items, or that they're real elements that we can render, but we don't know that. So we need to be a little bit more defensive now. I went back to hard coding a separator just as a first step, which is also, it's always a slash. And then we're doing this React.clone element. We're decorating each item that we render with some extra props that come in here. So now this breadcrumb item has a bunch of props on it that the user doesn't know anything about, which is a little weird. This is all to say, this isn't the simplest component in the world, but the usage, if I go back to the usage, is clean. We've exchanged sort of internal complexity of the component for external simplicity. So that's good. That's a good thing. That's a good trade-off to make when making React components. So the answer is that easy is not always simple, basically. So don't optimize for the ease of creating the component, optimize for the ease of use. And if we had wanted to save some time off the bat, we could have just looked at how other people do it, because there's a lot of breadcrumbs in the world that are made in React. So if we wanted to know exactly how to do that, we could have looked at some really popular UI libraries that I'm sure have many stars on GitHub. So there's Semantic UI, Material UI, React Bootstrap. All these are very popular. These are the approaches. These are all screenshots from their documentation on their breadcrumb components. And they all look pretty similar to what we ended up with. React Bootstrap actually ended up the exact same way. So we have, it's always useful to just see what's out there. One of the joys of working with a really popular library is that you have a lot of people that have walked the path for you before. You don't have to invent everything from scratch. So worth keeping in mind. So now we're gonna do the little pivot I talked about into just data fetching. We're just gonna touch on a data fetching pattern and how that can mess up your API. So, because we just talked about sort of a component that just renders UI, but we didn't really talk about what happens when you fetch data and what that can do. So to head back to my really awesome DocSpace page that I spent a very long time making. This app is interacting with two API endpoints. One is fetching information about a specific dog. It's fetching a dog profile. So it's getting the image and it's fetching the interests of the dog. and it's fetching an array of park IDs. So the park IDs are then sent to our second API, which is the parks API, and that results in this. So the parks API will return a park name, how many dogs are at the park, and the thumbnail of that park. So we have to fetch the dog, and then we have to fetch the parks, is how that works. So usually when we use REST, which is sort of the default way that we create APIs, at least the default way that I've seen, it's how that would work is that we would first go fetch that dog profile picture and parks visited. We'd get to have that array of park IDs, and then we would do this thing on the left here where we map over that array. We get the park ID, we pass that into a park component, which is great. So that takes the park ID. The component itself takes in the park ID from props. It renders. When it mounts into the DOM, it'll go fetch that park, set that in state, and then render it. So while it's fetching, and while it's fetching, it'll just show this loading. When it's not fetching, it'll show the park. So that's great. This is actually a really nice API from a React component perspective. We're able to render an entire park by just passing a park ID. That's super easy to keep track of, and that's super easy to understand. We have to do very little there. Park knows its own data requirements and fulfills them at the same time. So that's amazing. We have to do almost nothing in order to render a park, which is great. But the problem with this is over time, especially if you have a complicated application that's interacting with many different sources of data, there can start to be performance concerns. So because first what happens is we download all our assets, we download our JavaScript and whatever, and that first renders our profile page, right? And then our profile page renders, and once it mounts, it says, cool, I gotta go fetch a dog profile. So it does that, and we load, we wait. The dog profile comes in, and then we have the park IDs, and then the parks render, and they say, cool, I have my park ID, I gotta go fetch my data, and it does, and we wait. And then the parks will render after that. And also, what we know about network requests is that a lot of the cost of network requests isn't actually in the downloading of the things from wherever it's coming from. There's quite a bit of cost to setting up a network interaction. So this is just a screenshot I took of fetching a dog profile picture in my network tab, and half the time is spent on the pink orange stuff, which is DNS resolution and other stuff, and the blue stuff is the actual I'm downloading the content I want. So that's almost half the time is spent in not downloading stuff I want, but in just setting up the network request. So we can get quite a bit of performance, quite a big performance boost by just making fewer requests, which is interesting. So if we're using REST, we're kind of stuck with that. That's just the way that REST works is you fetch pieces of data, and that's, and that's okay. That's totally fine. But GraphQL can help us out with this problem. And I'm not going to go super deep on GraphQL. I know that it's not super adopted yet. I do have the good fortune to use it every day at work, and it is super nice. So this is just another bump for it if you're thinking about trying it out. So one of the main advantages of GraphQL is that, like React, it is declarative. You just state what data you want and how you want it. Well, there's only one way to get it, but you just state what data you want, and it'll give it back to you in the same shape. So for a dog, let's say we're fetching for this dog profile component. We're fetching a dog, we need its name, we need its profile picture, and we need the parks it's visited. This will be an array of parks visited, each with a name, a brief image, and how many dogs are currently at that park. Totally great. So if we were to do that, we would use this query component, which is a GraphQL thing where you just pass in the query and the dog ID, and it'll make that request for you. While the request is in flight, it'll return loading. When it's done, it'll return data. So if it's loading, we're just going to return a loading spinner. If not, then we have all the data we need to render the entire page, which is great. So, we're going to say the dog name. So it's going to be potato, the dog, and home dogs and the potato. Here's our trusty breadcrumb. Back again, and then we're going to render all the other information about the dog, like its profile picture and its interests. And then here we have the parks. So we're getting back this dog's parks visited. So it's dog parks visited, and we're mapping over it to return this information. We're passing a park into the park. That's a pretty clean API. But this kind of sucks because we've just totally borked our component APIs by doing this. Right now, the parent, which is the dog profile page, that actually fires out the query, actually it has to know all of the data requirements for the entire page that it renders. So any child that has data fetching needs, it needs to know about, and it needs to fetch that data, and it needs to pass it down the chain to wherever it's needed, which leads us in turn to prop drilling, which is when you're passing a piece of information all the way down a tree of components in React, and not every component actually needs that information. It just needs to get down lower in the tree. There's ways that we can get around that in React, but at the same time, it's just just the data fetching needs is enough to turn me off of that. But GraphQL is super fancy because it's the schema, which is this declarative data fetching thing, is typed. So it actually has the ability to stitch together bits of its own schema dynamically. So we can get around that problem of the parent needing to know all of the data fetching needs of its children by having each component declare those needs for itself. So we've swapped this park component that we used to have into a parks component, where it'll render all the parks for us. And it's going to declare its data fetching requirements right here with a fragment. And it's going to say, hey, we need parks, and we're going to need to fetch that from the dog object, which is the type of the dog field that we saw earlier. And this is the data we need that exists on the dog field. So that's great. And we're going to notice that there's this dog prop, which is a little weird because that doesn't really have anything to do with parks. But the reason is because since we're fetching data off the dog type in GraphQL, what we're going to end up getting back is everything that's on the dog type. And so what we've got, because we know that we need parks visited, but our parent component doesn't know that we need parks visited. It just knows that we need dog. So what this looks like to use is now this parent component will render parks, and it'll pass it dog, just data.dog, which is great. There's this dog query, and instead of enumerating all the things that the parks component needs, it'll just import those parks fragments that are just attached to the component, and it'll just chuck them in there on dog. So it requires this initial setup where you have to look at the parks component and say oh, this component actually requires something on the dog type, so I need to hook that up initially. But once you do that, the parent component no longer needs to know anything about the data fetching requirements of our parks component, which is great. If you have multiple layers of this, you can actually just keep rolling it up all the way up the tree. This works at one layer, but if our query was actually happening much higher, each component can roll up the fragments of the children it's rendering all the way up the tree if we wanted to. So this is a little bit of a trade-off, but ultimately sort of a happy one for me anyway, as there is no perfect API, as we know. But at this point, we've gained quite a bit of performance improvements, and our components still declare their own data requirements and fulfill their own data requirements to some degree. It's just you need to have that initial convention and setup to sort of get things wired together, which is why there's this one smaller unhappy child, but a mostly happy child here on the left. So with that, that's what I got about component API design and a data fetching trick or two.
I have a question if I can go ahead with it. Can you go back 2 slides? I think it is. I'm wondering how you set up, how Parks is aware of its children's data requirement.
Yeah. So so Parks actually doesn't really have any children from like a component perspective. It's just, so the Parks component is just saying like, cool, I need to render a div that has a name, how many dogs are there, and an image. So that's all it just says, cool, like that's the data I need, and I know where to get it from. So the leap here is that whenever we wire up the parent, wherever this Parks component is put, its parent needs to be aware, cool, I need to stitch that fragment that Parks is providing into whatever query is fetching the data for this page.
Okay, I said that backwards. So how does dog, can you show me the part where dog?
Yes, yeah, totally. So this is the unhappy child part of this pattern, which is that there actually isn't a way for this component, which is like the whole dog profile page. There isn't like any way for it to just intuit that's required. When you first render Parks, if you're setting this up and you're like, cool, I'm gonna need Parks, like, cool, I'm gonna pull this in, you're actually probably gonna have to go look at the Parks component and say like, does it have a fragment? Okay, cool. I'm gonna stitch that fragment into either my own fragments that I'm providing or into the query that I'm making. So that's, this part, the setup piece is manual. Like you'd have to just go look at Parks and determine like, yeah, this is what this needs and this is where it goes.
You'll have to require the Parks file in.
Yes. Yep. Yeah, you have to import the Parks component anyway. I was just sort of, this is already a lot of code to render, but you have to import Parks, which is, you have to import Parks anyway. And just looking at this, Parks is a component, which is weird. I don't have an export key on here, but it should have one. Parks is a function, but since it's JavaScript and everything's an object, we can just attach properties to it willy-nilly. So when we import Parks, we're getting the component, but we're also getting this fragments object just riding along with it, so we can access that. Wherever we import the component, we can also access the fragments.
Why do you give it a key of dog?
So the reason why is because it's possible that the Parks component is going to need more things than just something on dog. So let's say there was another field here called like current user or something like that that had like account ID or something like that. So it's possible that here we would need that user ID or something like that. And so we actually would need multiple stitch points, multiple fragments. So this allows you to specify, cool, for dog, this is my fragment. For some other part of the schema, you put it on a different key.
Gotcha. Cool.
Yeah.
Russ, do you test anything at a component level, or is that handled outside of this context?
Yeah, well, I don't know. I've actually gone through a little bit of, I used to use a lot of Enzyme, which is sort of a component testing library, which lets you test components and all its methods. And I've recently had a coworker who sort of swapped me over to React testing library, which takes a fundamentally different approach. It's more of almost like an integration test. It's more of like a an interaction you'd sort of think of happening in an end-to-end test, where it takes the approach of, instead of testing your component as you see it as a developer, the idea is you test your component as your users would see it. So it actually renders things out to the DOM, and you query the DOM for what's in it. In that case, like I find myself writing somewhat fewer tests that way, and the tests tend to cover more, so that the tests tend not to be on a per component basis, but on a series of interactions that a user would take. So you tend to be testing like user flows almost more so than specific components themselves, and the components just get tested at, almost by happenstance at that point. I think Kent C. Dodds wrote that library, and I think he's got a lot of great talks about that that philosophy and why he wrote that library, that I would heavily encourage checking out. It also makes your tests more consistent when you actually do a major refactor, and your components themselves change, but your UI might not. Your tests are actually a source of reliability, as opposed to when you use something like Enzyme, your tests have to change with your components, so you can't use them as a source of truth about whether your app is actually working or not. But when you use that more integration test approach, you can, which is nice.
Is that one of those things like Puppeteer that uses virtual DOM?
Kinda. It's not as heavyweight as that is. I actually don't know a ton about what it's doing under the hood. And I think it is rendering in a headless browser, but I am not sure about that. So
can you debug it in a real browser?
Yes. No, you can't. I don't think you can debug it in a real browser. You can do like things like you can toss debugger statements in there, and it basically prints out the current state of the DOM in the console. So a lot of times what you're doing is checking whether things are there or whether the DOM is in the state you expect it to be, as far as just like, it should say that there are 3 parks right now, and there should be 2 dogs currently there. You just make that assertion, and and you can you can print out whatever it has rendered to the console and like look at the state of the thing if your tests are failing.
That's called React testing library.
Yeah, I think it's actually, it might even just be called testing library, and there's a React variant of it. It is called, React testing library, and it is at testinglibrary.com. So I think, I think that it's been, you can, they've made variants for Vue and other popular UI libraries and frameworks. But I would definitely recommend it. I've found it to be a lot more stable and give me more confidence that what I'm writing is working, for sure.
Hi, Russ. My name is John. I have a question real quick. Thank you for your talk, first of all. I have a question about other, not frameworks, but like Next.js or Redwood.js and how they are adopting React and applying them to, making websites. If you have any.
I've never used either of those, so I would hesitate to pretend like I know anything. I don't. I briefly looked at Gatsby for a second. There's a person on my team who's doing something with Gatsby right now, and I don't have anything. I don't know anything about it besides it looks cool. But yeah, so I'm not sure.
Okay, yeah. Well, Next.js is probably further along than Redwood, but Redwood in about a year will probably be worth taking a look at. So,
cool. Yeah. I'll definitely give those a look.
Thank you for your talk.
Yeah.
I wonder, Russ, if you might, and say only as much as you're able, but, tie this back into kind of software monitoring.
Sure.
Your day job that kind of drives some of this, at least, is, the goals at New Relic. And, has the transition over to React been a little bit at a time? Because you've been there since before this was the main deal, right?
No, I've only been at where I'm at for maybe a year and a half, and it's so mixed deal. So it's traditionally New Relic has used a lot of, it was a Ruby shop to begin with, and that's what their product was based on for the most part. Their first flagship product was Ruby monitoring, and it was all built in Ruby, Ruby on Rails. And they have started to transition piecemeal over time to React. So they were sort of replacing things like in in place, they would have like statically rendered pages with some React injected into it in certain places. Over the last couple of years, they made a larger shift to use a platform that replaces the whole thing all at once. So they released that maybe a year ago, and it's created a lot of benefits. A lot of that's because of React, just because it's well known and it's popular. The platform itself is also extensible, and it's made up of a lot of micro front ends. So every team that works at New Relic basically just builds little React pieces that plug in to this platform dynamically, and actually like customers can build the same pieces that plug into the platform dynamically, because fundamentally most of what we do is just give people data, like give their data back to them however they want their data. So if they have some special use case for their data that we're not necessarily covering, then we let them build their own like micro front end that can plug into the platform. And it's the same system that we use. And that was actually the main impetus for using GraphQL, because we have a lot of APIs, many APIs. There are many services that expose many endpoints. And there's a lot to keep track of. And it was a lot to ask our customers to keep track of if they were, for any purpose, basically. So that is one of the huge advantages of GraphQL, is that you can provide one place to go look for anything. So it stitches together all those RESTful APIs that have different URLs, different data contracts, different API keys, whatever, stitches them together into like one unified place where you can just see like what you could get, what data is available to you. So yeah, so actually, I don't know if that answered the question at all, but
I think so. It sounds like it started out piecemeal, and that it's accelerated now, and that it is pretty much a shift for at least the front end of the whole platform is what they're going for.
Yeah, totally. And this is actually the second time I've done this. I actually had read a great article about how to refactor into like a newer technology. About like a bunch of different companies that try to do it. It's really hard. I've actually had the fortune of working for a couple of companies that have been doing that. It's really hard to shift everything over all at once, especially if you're an established, like New Relic has been around for a long time. It's been around for like 10, 12 years, or maybe more than that. And the company I worked for before, which is Marketo, same deal. They've been around for a really long time. And it's really hard to completely rewrite a front end that has a ton of features in it, because even if your UI is not great in some cases, your customers have spent years getting used to it, and they know the ways in which it doesn't work. So they've found their workarounds. They found their workflow that works for them, and even though your new front end might be better, if you rewrite it all in one big go, it's a real shock to the system, and you're asking your users to understand a lot about your product, and asking them to relearn a potentially really complicated tool. So it can work, but it's also really hard to go one big rewrite like that. And React is really good at piecemeal replacements of stuff, if that's the way you want to go. If like your main problem isn't the fundamental underpinnings of the thing, and you just want to like make a better drop down or something like that, React works really well for that, because you can just mount your React tree at like one point in your UI, and then it's just React from there. You can just like sort of inject it in spots, which is really nice. So there's no right answer to how to do a massive refactor like that, though.
There's so many wrong answers.
That's right. And the right answers can't be wrong answers. It seems like.
So I had a quick question. I'm like a stalker of GraphQL, but I've never used it in a production project. And not to be another like, have you tried this JS library, but have you seen GQ less? That you don't even have to write the queries. It just like, you access it like data object notation, and it builds the query for you.
Oh, that's really cool. I hadn't. I think there are a lot of cool things that you could do with GraphQL that
I didn't know if it did the fragment part. That was my question, actually.
Yeah, I don't know. I don't know if it does. I mean, I built a couple GraphQL servers at this point, and I did one where in Python where it's like usually you sort of build up the GraphQL. It's like a series of functions. They call them resolvers to like you resolve each field individually. So each field knows what data it needs to get, and then it kind of rolls that all up into a response. And I actually recently made one in Kotlin. But one of the advantages of GraphQL is that since it does have types, is that there's actually like libraries out there where you can declare the schema, and it'll actually auto-generate all the resolvers that you need to like build up like data fetching for the schema. So that's like a pretty cool thing. And also, so like I could see how that would work on the front end. I think that there's a lot of possibility there with GraphQL for just like making this stuff super duper easy. It also is like super great with TypeScript because it can just generate all your types for you if you're into TypeScript, which I am, and you should definitely try out if you never tried it. Definitely that, you know, when you are you in 4 months and you need to fix that bug and you forgot how that code works. It's really nice to have a type sometimes. And GraphQL works really great with that because you can actually get typed network interactions, which is magical.
When you're working building the GraphQL backend, did you run into the problem that you were describing on the front end where you need a dog and then a dog has a list of parks that they go to? So on the back end, you might end up making a SQL query for each park.
Yep. And and to be clear, I'm gonna call myself one of those T-shaped developers where, you know, like I kind of know front end and I can hack together a back end, and I'm just not that good at it. So yes, I have run into that problem and I have not solved it. So I think that is actually one of the really hard things about GraphQL is it's really easy to get into like a loop where you have like, yeah, a dog fetches parks, and then on a park you might have the dogs that have visited, and on that you might have a dog, and you can get yourself into this like loop of pain that like, and you can actually end up making like, when that translates, if you're like gluing together a bunch of RESTful endpoints, you can end up making like a ton of requests or a ton of queries to your database. So it is something you have to be really careful about. I don't have a lot of great strategies on how to avoid that. I work with people who do and haven't had the opportunity to delve deeper.
Okay.
Yeah.
Any other questions? Anything from Fairbanks?
I got one last React question. Just wondering, kind of in generally, when you're trying to figure out your component structure and like how big to have components and how complex, and like what are some of your like guidelines for like figuring out that process of what lives in what?
Yeah, I mean, it's hard. I mean, I still think like, I think that's the hardest thing, and I still think I've never come across like a definitive like this is how it is and this is how it works. I think that I think it's usually when you like step back and say like, what is this component trying to do, and like phrase it in those terms, and you're like, it's trying to do this and this and this and this, and if you start counting out a lot of things, and it's like maybe okay, like maybe this component's trying to do too many things. There is a pattern that like tends to happen to me anyway, where I make like a bunch of really nice components at the bottom, and as things go up, there tends to be one component at the top that tends to get a little out of control, that like does the data fetching and starts handling a lot of operations that interact with the rest of the app. So it's hard. I don't have any hard rules on like how big a component can be or how many things it can do. And I think it really depends on the app and how much time you have to build something, you know, kind of to know. So I don't know. Hopefully that was speaking to what you were speaking to.
Anybody else? Going once. Going twice. All right. Well, thank you so much, Russ. This has been a super interesting talk. I definitely have some more for myself once I kind of digest a few of these things. I haven't dived into React components before, so looking forward to getting some more background on that.
Yeah, totally. And if anybody like wants to chat about this or anything at all that I might have talked about or whatever, just totally feel free to hit me up in Slack. And happy to chat.
Will do. Let's see. Do we have any announcements before next meeting? Arsh or Dave? I don't think so. Okay. Well, in that case, hope to see everybody 1 month from now. We're going to have Claire Cortell, who's a data scientist for Lyft, talking about her work as head of mapping with them. So with that, I wish you all an excellent weekend. Hopefully the weather improves and everybody gets a little sun outside.
Thanks. Everyone have a good weekend.
Thanks a bunch.
Thanks, Russ.
Thanks, Russ.